This is a short movie just to explain the principles of ground reaction forces during running. On the screen at the moment we can see a runner during a single foot fall in three positions. Now if we look at the forces generated during a single foot fall at those three positions, we can see, according to Newton's law, as the runner pushes down on the ground pushes back on the runner. So in position 1, the first position shown on the left, the force actually acts slightly backwards as well as upwards on the runner. At the mid-stance position, the force is acting vertically upwards, and then towards the end of the stance phase, towards what's called toe off, then the force starts to act in a forwards and upwards direction. Now if we isolate those vectors and we show their components, we can see that the ground reaction force associated with the point during stance early on has a vertical component and a backwards acting horizontal component. The mid stance just has a purely vertical component, and the point just before the end of the stance has a vertical component accompanied by a forwards acting horizontal component. Now if we collect all of the horizontal components that are acting on the runner during the period of a single footfall, then you would get a graph or trace similar to that shown on the screen. Notice that in the first half of the footfall the force is shown to be negative, i.e. as the force shown here is the horizontal force component, this is a force acting backwards on the runner. In the second half of the footfall, where the trace is positive, this demonstrates a ground reaction force horizontal component acting forwards. Similarly, if we look at the vertical component and collect the instances over the period of the footfall, then we would get a trace similar to that shown on the screen at present. Initially there's a sudden peak, sometimes known as the impact peak, which normally is immediately followed by a slight trough, and then a second peak, sometimes known as the active peak, where the runner is once again thrusting in the middle of the footfall. Now we can gain further information from these traces by looking at the area under the curve. On the screen at the moment this shows the area under the horizontal ground reaction force trace. This area represents what is called the impulse of the force, i.e. force times time. That's why it's the area that is representing impulse, as the force factor is represented on the vertical axis, time on the horizontal axis, so multiplying those two together, force times time, is represented on the picture as the area under the curve. We have a negative impulse followed by a positive impulse during the stance phase. Therefore, if we were to combine these areas, taking into account their signs, we could obtain a net impulse. A simple rearrangement of the impulse momentum equation can show that by calculating the impulse, dividing by the mass of the runner in this case, we can actually get an estimate of the change in velocity experienced by the runner. In the same way that we consider the impulse of the horizontal component affecting the runner, we can also consider the vertical impulse. In the diagram we have on the screen at the moment, the shaded area represents the vertical impulse generated by the ground reaction force. Now, in considering the vertical component, one has to remember that the runner would not in fact be solely affected by the ground reaction force component. Indeed, we would need to take into account gravity. So in the trace here we can see both the ground reaction force impulse and the gravity impulse. Now the gravity impulse is shown as a negative area. This is clearly being generated by a force acting in a constant direction, at a constant value in a downwards direction, and this of course is the force of gravity. Once again, if we wanted to get an estimate of the net impulse, then we would take the negative area away from the positive area, and you'd be left with the shaded area as shown on the trace here. This concludes this short explanation.